Thank you very much. So unlike the last guy, I'm not afraid to just show you my password, I guess. So I'm just going to copy it over there. Tell me how many characters that was. So really, I just use my mobile phone to authenticate to my system. The point here is that how do you make YubiKey and Android become friends? Is basically the point of this talk. So I'm David Weinstein. I'm a mobile security engineer at Via Forensics. And my talk is Stronger Identity Protecting the Mobile Devices. So how did this talk really come about? Well, Andrei Zelenko, who's spoken at PasswordsCon before, he actually mentioned you guys to me. I hadn't been to any of these conferences before, and basically said that some of the work, the research I've been doing in turning a mobile device into an attack system, attack platform, whereby I was turning the phone into a remote keyboard, would be interesting, and it could be used to basically improve the state of password management in this space. So some of the goals of the goal of this talk is basically to make strong passwords available to your mortals. I'll look at some of the existing solutions that people generally use. How many of you guys use a software password manager? And how does it work on your mobile devices, I guess, or do you run it on your mobile devices? And also, yeah, okay. So cool, I'll talk a little bit about that. Unfortunately, I don't solve the problem of how do you authenticate to a mobile device, but I do help the problem as far as authenticating to other devices. So, big problem, right? Strong passwords, this seems to be counter to usability. It's hard to remember long and complex passwords, and users are generally terrible. So Andre basically said that if you could do any one of those five, you're probably doing pretty well. And most people are terrible at all of them, so there's a big problem, right? Yeah. So an ideal solution would try to balance, usability, scalability, secure generation storage. We kind of heard some of that stuff about the HSM module, and that's really awesome. I think that because we carry mobile devices, we can sort of get a high level of usability by repurposing them for storage of passwords. And sure, you can attack them, but at least we can kind of improve the overall state of security by leveraging them. So my ideal solution is one that is scalable in the sense that I can use it for storage of a lot of different passwords and authentication for different websites and services, and use my local system, my laptop. That it's portable in the sense that I can bring it with me, and it's going to be usable when I want to get to other systems. So if I'm on a random computer that I don't necessarily trust, there might be a way to generate a one-time pad and use that to authenticate to the system temporarily. And of course, secure generation and storage. Well, humans are really bad at generating secure passwords, but it turns out computers, of course, are really good at generating basic random entropy. So we can basically use high entropy long passwords all the time if we take advantage. And that's pretty much all. Those are the dimensions that at least I could think of when I was thinking about this problem. I'm curious if anybody has any other dimension that I'm missing. If you want to pitch it in, tell me. But I hope I captured most of those dimensions. So what are the existing technologies that people use? 1Password on mobile devices. LastPass, I guess, is another one, but 1Password on mobile and desktop systems. Google Auth. How many of you guys are using Google Authentication for second factor? Yeah, I'd say that's pretty popular. Duo Security has their platform. I'm curious how many of you guys are using that for. Yeah, cool. RSA Secure ID, most of the big companies that I've worked for in the past have used RSA Secure ID, so those are really, those are the main technologies that I see people using it. And another big one that I really like is the YubiKey, because it's a dedicated device to store static passwords, and if you're willing to put your password somewhere in a third-party system, then you can sort of have a central point of management and use the YubiKey to basically, as a single hardware device, to send those passwords to your system. And the really nice thing about YubiKey is that you can use it anywhere, right? It uses the human interface device, so it essentially looks like a keyboard when you plug it into any system that receives a USB device. So, my thinking here is how can I take advantage of that usability and put it on a platform that we already carry with us and still maintain the level of scalability that using something in software gives us. So, software-based password manager. So you already have a smartphone, right? Why not let it type the password and let it be under the UV key in your pocket? So I already alluded to this, but that's basically what this is about. The idea here is I took a open source application on Android, so I did this on an Android device, mixing hacks to the Linux Android kernel at a really low level in the platform, which kind of is an issue, which I'll get to in a little bit later, but the idea here is to combine this low-level modification with user space application and make it so that the phone, when plugged into another system, looks like just like a keyboard, like it does with the UV key. So why pick PasswordsCon? Well, it's the first one. I asked a few of my friends, and it's the first one that came to mind. And it had a pretty good rating for being up on the Google Play Store. It had about 20,000 ratings, so that it's open source, has a familiar user interface that people have been using and find helpful. And it only uses a local database, so it's not something that's, so I'm pretty paranoid. I'm not going to store my passwords in a third party in the cloud. So I actually like the idea of having a local database. And it does still fall prey to the issue of having at least one single point of failure. If your device is stolen, of course. I work for a forensics company. I know it's possible to extract information from mobile devices. And basically the idea is you have a local database that's stored with a master key. That master key is derived from a number of, I think it's like 6,000 rounds of AES encryption. And you guys probably know a lot more. I'm actually a password weenie. But basically, the idea here is somebody else figured that stuff out for me, and I didn't want to reinvent the wheel, so I used that open source application that already was out there. So Android. Android is great because basically it's designed to do a lot of the things that I wanted it to do. Basically, we already use these Android devices for tethering, for doing Ethernet tethering. We plugged our phones in to charge our computers, or to charge the phone, with other systems. And of course, there's the existing media transfer protocol. So some of my time was spent understanding these existing protocols and how to sort of hack them to do what I wanted. And so Android calls this basically, it's effectively a Linux thing called gadget mode. And any mobile device, any modern mobile device has this USB hardware called on the go that lets it switch roles between being a USB host device and a USB slave device. Our laptops and desktops generally just have the host-based hardware, whereas our mobile devices tend to have this on-the-go hardware. So Android accessories, this is what Google tells you it's for. It can be used for audio docking, for interacting with exercise equipment. They have the grand goal of the Android device being the central platform on a robotic system. So, it's very hackable, but unfortunately it's not hackable to the point where I could very easily add this hidden human interface device to the platform without hacking the kernel itself. So my thought was why not the laptop or desktop be an accessory to the mobile device. So this is kind of how it works conceptually. When you plug in a USB device to your laptop, the laptop sends an enumerate command, and the phone basically responds with some information like I'm an MTP device. MTP is basically a media transfer protocol that lets me transfer pictures from my phone to the laptop. Next, you have something like a human interface device. So basically, this is the part that I added, right? The phone announces that it's a keyboard. The laptop or desktop loads the corresponding driver for that human interface device. So one of the other really nice things about this approach is that any device that supports keyboards essentially supports this approach to authentication. So then we have the human interface device, and then basically the way that USB works is you have 8-byte sequences that correspond to it's like a lookup table. Depending on your keyboard type, if it's a US-based or other country, then there are different mappings. But the basic idea here is there's an 8-byte that represents how many keys are being pressed and also what key is being held down. And so in this case, the 0x0004 8 bytes is corresponding to A, B, and C. And so when you want to send these keystrokes over the USB interface, you basically just generate these 8-byte sequences corresponding to those characters that you want to send over, and the other system on the other side interprets them accordingly. And of course, you get your ABC on the other side. So you've already seen a mini demo of how this works. At least I use it to log into my laptop. And here I'm going to try to give a little bit more of an idea of how this might work practically for other people. So let me just switch screens. I'm going to do this in the emulator, but the actual sending of keystrokes won't work in the emulator because there's no actual USB hardware to interact with. And then I'll just basically show you that the same thing works on my mobile device. And this is just mainly to give you a feel for the user interface and the experience. That's interesting. It seems to be sending all sorts of weird characters.
Your pointer's offset in the emulator.
Yeah, thanks. All right, so you basically would run the app from all right, so when you first start the app, you have to unlock the database, so you basically type in your master password. So in this case, it's just test. And of course, that's where the big issue lies, right? Like, how do we still authenticate with our mobile devices? And what I'm thinking of doing here actually is basically to use an NFC tag, bring it up close to the mobile device, use that to unlock my password database. I'm thinking about this from my personal perspective because originally I was doing this all for my personal use. So I'm sort of sharing this with the rest of the world in the hope that other people might find it useful. But right now, that is the weakest link and the recovery of the information from those databases. So here you can basically create your own, your new passwords. And unfortunately, I can't really see the interface well enough to add a new one, so I'm just going to show you one that I already had. So here's one that I pre-populated, and basically, totally randomly generated password. I think this one was 120 characters long. So what I'm going to do now is basically bring up a text editor in my console system, and I'm going to use the mobile device to send this same actually it's going to be 1,024 character password to my system. So I don't know if there are any systems that can actually receive 1,024 characters for password, but I'd like to see that happen now that we can use this technology.
I think you can use it with Hotmail, it just truncates it slightly.
So how many did you actually
16.
That's too bad. So here we are typing a 1,024 character password. And I'm sure you guys have seen this kind of thing before with like a teensy USB device, so nothing really new here, but it's really the using the mobile device there is the huge win, I think.
It also helps with keystroke content analysis too.
Sure.
How fast can you inject keys before it drops keys?
I haven't actually figured that out yet. So whenever I'm sending a keystroke, I'm actually only sending one keystroke. You can send up to 8 at a time, and I'm not sure how, because basically you can send down all 8 keys being held down at the same time. So in theory, the bandwidth could be a lot higher than what I'm doing. It's just a question of Google receiving system, when it sees that 8 keys are being held down, how will it deal with that, right? But in theory, I could send the fact that 8 keys are held down with those 8 bytes. Maybe it's fewer because 7 of the bytes, one of the bytes is reserved. So, and one of the bytes is used for control modifiers like control, shift, and alt. But in theory, we could get pretty high bandwidth from that. Obviously, sending 1,024 characters took a little bit of time. It wasn't instantaneous. And it's also going to be limited by what the OS accepts, and that's probably what you were getting at. I'm not sure what the OS will do to drop keystrokes. So modifications to KeyPass Droid are open source, or will be open source. It really won't do you any good unless you have the actual kernel modifications. So basically it's useless until that actually gets taken by somebody and implemented and put onto other devices. The kernel patch ends up being around 200 lines of code, so it's actually pretty small. Something that I could probably get Google to add if we push hard for it.
You also might have luck with the third-party kernel developers.
So like CyanogenMod would definitely be a good one to approach, yep. So yeah, if you guys are running CyanogenMod on your systems, hopefully I can get this pushed out to them pretty soon. So here, basically we need some kind of key descriptor. So every keyboard and every hardware device has a descriptor that corresponds to what it is. You know, whether it's a US-based device or another particular country. So that's important to get right depending on where you're implementing this. So basically you can grab these descriptors from any hardware device that you have and use USB Probe on Mac, or you can use LSUSB to grab these descriptors. So the idea here is that I can make my phone look like any arbitrary keyboard. Some of the challenges is that this is a patch that's basically being done on a per hardware device, per Android device basis. So I've done this on my Galaxy Nexus. It's not clear to me how this scales, because it requires root, obviously, to be able to put this on your platform. And so I'm not sure how that would scale to other devices. That was part of the reason why I kept it mostly for personal use. But I'm hoping that maybe somebody here could put me in touch with the right people. CyanogenMod sounds like a great way to do it, so actually I hadn't thought about that.
Yeah, I mean, there's a number of third-party kernels for all the various devices, and I think it would be very easy to get some of the developers to add these patches, and then people who are running custom kernels could just upgrade to one of these kernels. It should be fairly easy. I actually know a few of the kernel developers,
Awesome.
So ping me later.
All right.
Later as well.
So I'm hopeful because Linaro, which is an open source Linux guys, basically they're pushing really hard to move some of this low-level kernel stuff actually to user space. So it's possible that in the future these Android devices will implement that media transfer protocol and those other low-level protocols pushed into user space. So in theory, we won't need root. We might need root, but we won't need a kernel patch to do some of these things. So. Yeah, I'm interested in whether or not that'll help this situation out. Of course, this whole approach is not as secure as dedicated hardware. I know from a forensic point of view that the device can be compromised and the data can be recovered. I'm sort of sorry that I don't have a whole lot of background on how to generate really strong passwords. That's not really my area of expertise. I'm kind of hoping to just sort of share this this ability to deal with the local system to you guys. Some of the things that I'd like to do in the future, this is where I'm really open to new ideas, is basically, could I take a snapshot with my phone of a QR code on a web service and use that to see my password generation or my next password? And I think that there's a lot of really cool ideas that could come out of using a more sensor-rich platform like a mobile device to help, this whole password situation. I really think that if everybody started using this kind of technology, it would be a lot harder to crack passwords on the back end. So I think Andre really wanted this to get out there because it's kind of a disruptive technology if it were actually take off. If you take out of the hands the need to generate passwords from the human and give them a tool that'll work on a more usable way, then maybe those challenges, all those tables that you guys have generated will be almost useless, I guess. So maybe it'll make your jobs harder, I don't know. But still we have that problem, I guess, of authenticating to the mobile device. I'm thinking about releasing also sort of like an API to, maybe there are other ideas that people could come up with using, having a phone be able to type arbitrary things. So I don't know, so the sky's the limit on that. Obviously this is just a proof of concept. My company has no real, I don't think any plans right now to commercialize any of this, but basically, we're hoping that somebody can actually build this as a real tool. So that's it. If there are any other questions, I'd be happy to take them.
Have you looked into doing this via Bluetooth at all?
Yes, a little bit, and it's not that hard. Actually, it's just sort of a usability issue. Like, am I going to pair all the time, or do I just set up a single pairing? Bluetooth is obviously vulnerable to some, man-in-the-middle attacks with capturing wireless. But yeah, I definitely have another proof of concept that does it with Bluetooth. So I like the idea of being able to walk up to any other system and just plug in and use it, right? Bluetooth, I have to still go through that pairing process, and I'm not sure how it works with, so I can currently use this as soon as my laptop boots up, so I can use it to decrypt my whole system. I'm not sure how that works with platforms where I haven't previously authenticated with Bluetooth.
Sure.
Yeah, but that's definitely another nice way to go.
Just a lazy question.
Yeah.
Mr. Derek, what is KeyPass going to use to license like mobile encrypted storage?
So I believe it uses AES-256, and it generates that password it generates that master key after 6,000 rounds of basically taking your password with a solve and goes through the 6,000 rounds. I think it does a SHA-256 on that, and then uses that as the uses that to unlock the password or to unlock the rest of the database. But yeah, I'm not an expert on that stuff, so I'm not really sure. You could easily dive into the code, so it's open source.
Yeah, I was looking at it.
Yeah, sure. Anybody else? Oh, in the back?
Yeah, I think you talked about a problem being authenticated into your mobile device like your Android, and I'm wondering if there's any taxing Android to act as a biometric sensor, so that if you just put your thumbprint on the glass, kind of do a thumbprint or eye for a scan possibly is another method of keeping a lot of your mobile.
Absolutely. I think yeah, that's an interesting comment. I mean, because we're using such a sensor-rich platform, there's all sorts of different ways to capture information about the user. Why not use that basically to authenticate the user to the device? Yeah, definitely. It sounds good. Sure, good.
So I noticed in your really long random password, the slide, or when you were showing the demo,
This one,
well, it's the one that was actually displayed on your device. I guess it was in the middle of your password that it actually showed. Yeah, the U7U less than. I thought the fourth character in your password was actually less than. If it was, there's this one CMS that truncates at the first less than sign.
uh-huh.
So it would be 3 characters long.
Well, so this
I
password,
just thought it was funny.
Yeah,
I saw
that is
that, I was
funny.
like, oh.
that
But
is
it's
funny.
actually longer, yeah.
So obviously we can customize the generation of those passwords. That's not really something that I did a whole lot of on KeyPass, but I think that maybe this increases the usability of the app, and so maybe people improve the state of it. Any other questions? Yeah.
I've implemented something like that in hardware. And on mine, I implemented 2-factor authentication. Have you thought about doing the same, like Google Authenticator and UT built into the app itself to be able to generate the one-time password rather than like opening up the Google Authenticator app and typing it in?
Right. Yeah, so that definitely seems like something that we could do. There's no Google Authenticator. Well, maybe there is for Android. It probably is. Then if it's open source or hackable, we could probably have it added in. Not a big deal. Yeah, definitely. Thanks. Anybody else? Yeah, go ahead.
Just 2 things.
Sorry.
About Google Authenticator, you had mentioned scanning just scan the code using that to see.
Yeah.
That's exactly what Google Authenticator does.
Right.
And so that code is all.
Oh, so I can just reuse that, is what you're saying?
Yeah, that's up there. And of course, just to say, this of course could be, your technique could be used with any password manager.
Right. So if there are any Google people out there, just add this in. Yeah. All right, cool, thanks.
Okay, go.